We're going to go ahead and start our little mini trig unit that we'll finish off from now till spring break with. So it should be a nice change up from what we normally do. You know, for one, it's quite a bit different than the math we typically do. You geometry kids have already seen a lot of this stuff this year, you all who are doubled up. And if not, you've seen it in the past. But this is just basically designed to help you guys review before you go into pre-calc. We don't finish up with a test for this. We finish up with a nice, kind of hopefully fun project before spring break. So we don't even have any math XLs for this. We have just some kind of worksheet work. So it should be a nice change up, hopefully. But either way, that's what we're going to do. So today we're going to focus on just the basics of some trig ratios, and then also how to use those trig ratios in some special right triangles. Okay, Parker, would you mind shutting that door for me? All right, so just some vocab to start. A blank compares the lengths of two legs of a right triangle. We're going to say a trig ratio does that. And we'll go over what those are in a second. And then the Greek letter theta, I accidentally made my O a theta in ratio, is used to represent the measure of an acute angle. So it is, it's just an O with a little swoop through it. Okay, you can see a better example, you know, from a computer here, here, and here. Okay, so that's theta. Doesn't really matter that you remember that that's called theta, but that's what it is. It basically is just kind of like a variable. All right. So let's go ahead and kind of look at some definitions and then a couple of maybe examples. All right. So sine of any angle, to find the sine, you take its opposite side over the hypotenuse. Opposite over hypotenuse. I'm just going to abbreviate that OPP over HYP, or probably easiest O over H. Right. And cosine is going to be adjacent over hypotenuse. I'm going to put ADJ over HYP, or just A over H. And tangent is opposite over adjacent. So I'm going to put OPP over ADJ. Or O over A. Okay, now, so obviously the triangle at the right is not labeled. So let's go ahead and just say it's obvious that this is the right angle. Okay, so then we could call either this angle or this angle theta. For our demonstration here, we'll call the top angle theta. And so, just as far as what do words like adjacent, opposite, and hypotenuse mean? Well, hypotenuse is always opposite the right angle. We know that. Opposite is the leg that it doesn't touch, right? So that's opposite. And then adjacent is the other leg that it does touch. Okay. Now, as far as remembering all these ratios, like O over H, A over H, O over A, there is kind of, I don't know if acronym's the right word, but there's this SOHCAHTOA thing that you may have hearing of in the past. That's what I like to use. So it's not, you know, a real word. I think somebody had part of an acronym. Does somebody know an acronym to go with that? Something about homeless or something? No. I've never heard it, but some kids started it earlier. No. Okay. For you people watching the video, they are currently looking at me like I'm crazy. So it's, wait, am I doing that wrong? I am. Sorry. I'm sorry. So so the next is KAH, and then TOA, TOA. All right, so SOHCAHTOA, right? So obviously that's not a real word, but it can help you to remember. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and then tangent opposite over adjacent. I think just, you know, the more we practice, the more you'll get used to that. Okay. And then we have the inverse of each one of those. So cosecant, sometimes you'll hear that called, I think, as arcsine too, but cosecant is the word that we will kind of use for the reciprocal of sine. So if sine was O over H, then its reciprocal would be H over O. All right, on the calculator, when we start to use our calculator, not today, but in the future, the button for this is, looks like sine to the power of -1. All right, and secant is the reciprocal of cosine. So if cosine was A over H, then this is H over A. As far as your calculator goes, again, this is more for the future. That button would be, looks like cosine to the -1. And then the easiest one to remember of these, like, which one does it go with? Cotangent, because it has the word tangent in there. That's the reciprocal of tangent. And again, we just learned or reviewed that tangent is opposite over adjacent. So its reciprocal would be A over O. And on the calculator, this button would be, looks like 10 to the power of -1. All right, so again, just kind of draw another similar diagram to what we just did. So let's say if we call this angle down here theta, then where would adjacent and opposite be? So hypotenuse would still be in the same place. Opposite of that theta would be here, and then adjacent would be there. So just getting used to where everything is. Okay? All right. So now I am going to kind of fill in some stuff on this triangle and ask you to try to find sine, cosine, and tangent. Yes, Faith. So adjacent is the leg that touches the angle. Opposite is the angle that doesn't touch the angle. No, when we're talking about of an angle, we mark that with theta. So like in the last example, we were looking at this angle. So what's opposite that is the leg it doesn't touch. What's adjacent to it is the leg it does touch. Okay? Opposite the right angle is always the hypotenuse. Does that answer your question? Okay, let's do some more examples, and then maybe sometimes you just got to see some numbers in there. That's kind of how my brain works. Anyways, let's say this right triangle has dimensions. Short leg is 5, long leg is 12, hypotenuse is 13. So given that and what I just told you, try to figure out what sine, cosine, and tangent. Okay, I won't call on you or anything, but just give it a shot, and I'll go over that in just a sec. Oh, sorry, you need to know what's theta first, right? Because we don't know if we're, if I give you that, we don't know if we're talking about this angle or that angle. Okay, so let's say theta is this guy right here. Okay, so sine of that angle, cosine of that angle, and tangent of that angle. Okay, so go ahead and just set those up as fractions, and I'll review the answers here in just a sec. Looks like our microphone's still working, so this is as long as it's made it all day. So you guys are just my favorite class. Everything just works better in here. We got bar jokes with Will Conway in the down hours, and I'm just messing with you. Just talking about your inappropriate jokes you tell and stuff. Yes. All right. So sine would have been 12 over 13. Cosine would have been 5 over 13. Just a mental note there. Sine and cosine are always going to be between 0 and 1, right? If they're over the hypotenuse, hypotenuse is always the longest side, right? So sine, cosine, always some number between 0 and 1. Tangent, it just depends what angle you're looking at, okay? So in this case, tangent would have been 12 over 5. So obviously that's not between 0 and 1. That can be bigger than 1. Okay. Questions on those? If you can do those, you can do their inverse. Everybody good with seeing how? Good. Okay. All right. So cosecant is the inverse or the reciprocal of sine. So we just do 13 over 12, and then go down and secant we relate to cosine. So 13 over 5, and tangent is related to cotangent. So we just flip 5 over 12. All right. So, anyways, just basic stuff there. Okay. Any questions? All right. So now let's do more like what I'm going to ask you to kind of learn or do a few homework problems on. Okay. So we're going to be really focused on in day 1, which is today, these special right triangles. And there are 2 types of special right triangles. One's called a 30, 60, 90. The other one's called a 45, 45, 90. Okay. So the reason we kind of study those first is because they always come in the same proportion. No matter what their side lengths are, they have the same proportion. Okay. So again, I'm not doing any math here, just giving you more definitions. But the ratios for side lengths of a 30, 60, 90 are 1 to the square root of 3 to 2. Okay, so let's put that on a diagram, what that kind of looks like. All right, so that's obviously our 90 right there. The smaller of the 2 angles would be our 30, so this would be our 30, and then the other one is our 60. Okay, so the one side is opposite the 30-degree angle, right? So we'll call that the one side. The square root of 3 side is opposite the 60-degree angle, so this is square root of 3, and then the hypotenuse is the longest side, so that would be your 2 side. Okay, so you could think about it like this, or you could think about it like on a more algebraic level. If we call this side x, then this side would be x times the square root of 3, and your hypotenuse would be 2 times x. Just different ways to think about that. Okay, so again, no reason you should have known that, but it's just a more definitional thing. Okay, 45, 45, 90s. Obviously, again, this is the 90, so your other angles are 45s. So those ratios go as follows. The 45s are the same, so we say those are 1 to 1. And then the hypotenuse, how it relates to those is it's multiplied by the square root of 2. So 1 to 1 to the square root of 2. Okay? So each leg is the same. We'll call it 1 for now. And then the hypotenuse, if those are 1, is the square root of 2. Okay? Or again, if we thought about it more algebraically, we could say the legs are both x, and the hypotenuse is x times the square root of 2. All right, so that's what we're going to be focused on in our last kind of example or so, and then I'll give you a little bit of a worksheet where you could try. Okay. All right. So first of all, make sure you're using the right diagram, and then we basically want to kind of set up a proportion from there. So in number 1, we are looking at the 30, 60, 90, right? So, which sides are we given? We're given the long leg and the hypotenuse, right? So when I go to set up my proportion, I want to make sure I do the long leg and the hypotenuse, right? So I can use those 2 sides as a ratio. So I can say like the square root of 3 goes with 2. Just like 9 goes with x. Okay, that's not the only way you could set that up, but that will work. Okay, so any questions about how I set that up so far? All right, and then we just try to solve for x. Okay, so we just use cross products, right? If we're solving a proportion, 9 times 2 is 18. X times the square root of 3, and we'll just call it x square roots of 3. All right, so then to get x by itself, we just divide by the square root of 3, of course. So we'll say 18 over the square root of 3 is equal to x. Now, 18 over the square root of 3 is correct, but it's also, you need to simplify it, okay? So this is how that goes. And you'll get better at this, I promise. We'll practice it a bunch. But you would go like this. So you'd say 18 over the square root of 3 is equal to, think about why this is true, 18 square roots of 3 over 3. So we've done this before, but it's been a while. So that's one of these things you're going to have to maybe look back at. And then from there, we can say that's 6 square roots of 3. Okay, so that would be using a proportion. We're going to talk about maybe a way to use more of a number sense strategy on the next two, but this is using a proportion. Okay, so 6 square roots of 3. All right, now let's look at the next one. Okay, so on the next one, I'm looking at a 45, 45, 90, and I have a leg and I have the hypotenuse, right? So either leg is the same. So I want to use a ratio of 1 to the square root of 2. 1 to the square root of 2. So we'll say 1 goes with the square root of 2, like x goes with 5 square roots of 2. Everybody kind of with me on how I set that up? Then we just try to solve, right? So then we have x square roots of 2 equals 5 square roots of 2. And really, you can almost solve that by fill in the blank, right? Anybody tell me what x is yet? 5, right? So you can almost fill in the blank, but algebraically how it works is, divide both sides by square root of 2. We get 5 square roots of 2 over 1 square root of 2. These two cancel each other out, and just 5. And again, maybe you could tell that just by looking at the diagram, right? So this will lead into our next couple examples, right? So again, the diagram says, if this is, if this is x, this is x square roots of 2, right? So again, you can almost just fill in the blank. X is 5, right? You don't necessarily have to solve it so formally like I did, okay? All right, so I want you guys I'm going to give you a couple minutes to get ahead of me, and you can make a proportion or try to solve more like with mental math, but try to do 3 and 4. Okay, so 3, you're using the 45, 45, 90 model. 4, you're using the 30, 60, 90 model. Just give it a shot. Okay, be willing to try and fail here. Yes. You could, but then you would just have to do the other side as 5 square roots of 2. Right. So like on this one, I did leg over hypotenuse. So on the other side, I want to do leg over hypotenuse. Yeah. If you're stuck, I'm going to put some kind of clues on the board. All right, so I wanted to give you guys a chance to get ahead of me. So if you were setting up proportions, like, Carson asked on the last one, why couldn't we have done like the square root of 2 over 1? The answer was we could, right? But that would just affect how the other side looked, okay? But anyways, looking at number 3, you needed to be using the numbers, 1 and the square root of 2, one way or the other. And then when we solve this, we get basically x equals 18 over the square root of 2, which is equal to 18 square roots of 2 over 2. And then we get from there 9 square roots of 2. All right. Yes.
Where are you getting the square root?
Just from our ratios up here. So I know it's a 45, 45, 90, and then I kind of look to see what they give me. They gave me a leg and the hypotenuse. So that is that part of the ratio. Does that make sense? Anybody got anything else? All right, nice question. Thank you. All right, and then number 4, again, using the other model here, the 30, 60, 90. So they gave me the hypotenuse, and then it matters which leg on this one, right? They gave me the long leg, okay? So you needed to be using on your first fraction, the square root of 3 over 2, or the inverse of that, and then x and 14 square roots of 3. Okay, so when we solve here, we just get 2x. Focusing more on the algebra here, you may have had trouble if you got this far with that multiplication. So that would just be 14 times the square root of 3 times the square root of 3, right? Which is just 14 times 3. Okay, so that gives you 42, and just divide by 2 to get 21. So by no means is how I'm showing you this the only way to do it. I'm showing you a very kind of rigid process. You can also use your good number sense and problem solving skills. So just talk you through like number 4, maybe a different way. Okay, so looking at number 4, I just showed you how to get x equals 21, the way we've kind of thought about it. You could also think through it this way, okay? So I can easily relate the hypotenuse, 14 square roots of 3, to the short leg, right? Because on this model, the short leg is half of the hypotenuse, right? So if I cut this in half, I get 7 square roots of 3 here, right? I can do all this in my head, right? And then to get from here to here, I just multiply by the square root of 3, right? So then I think 7 square roots of 3 times the square root of 3 is 7 times 3, which is 21, okay? I don't know which makes more sense, but you can approach it either way, okay? All right, so we're going to go ahead and finish with this little table at the end, and I'm going to leave those other examples blank, but they will be on the filled out notes, okay? All right, so sine, cosine, and tangent for all of our 30, 60, 90, and 45, 45, 90 triangles. And the microphone's still working. We're good. All right, so sine of 30. So first of all, kind of understand, that 30 is theta in this column. All right, so when I think of sine, again, SOHCAHTOA if it helps, opposite over hypotenuse. So that would be 1 over 2. Cosine, that's adjacent over hypotenuse. So square root of 3 over 2. And then tangent, TOA, opposite over adjacent. So 1 over square root of 3, which again, we're going to do this a lot, so this is good. That's equal to the square root of 3 over 3. And again, I haven't talked a lot about how we're simplifying that, rationalizing the denominator, but that's something we can look back and talk about tomorrow. Okay. All right. Then when I'm talking about my 60s, now I'm thinking, okay, this is my theta, right? So sine of 60, so that would be the same as the cosine of 30, square root of 3 over 2. Cosine of 60 is the same as sine of 30, 1 over 2. And then tangent would be the square root of 3 over 1, or the square root of 3. All right, and then for our last column, the 45s. So somebody asked, how do we know which 45 they're talking about? The answer is it doesn't matter, right? I could think of this one or that one. It's all the same, okay? So sine of 45 is going to be 1 over the square root of 2, which is the square root of 2 over 2. Cosine is going to be the exact same, so square root of 2 over 2 ultimately. And then tangent is 1 over 1, which is 1. Okay. Anyways, that kind of concludes our lesson. So let me go ahead and stop the video, and then I'll pass out kind of some drill work that you can do to help.